All right, I think it's 14:30, so we are ready to start. I hope you see and hear me well and you can see the presentation. I'll be monitoring the chat, so don't hesitate to let me know if you experience any issues. So hello everyone, I am really happy to see all of you who were able to join my session at Positive Technologies today. My name is Kristina Devochko, and today I will be talking about managed Kubernetes service and day zero survival pack. So before we kick it off, I would like to just share a few things about myself, and also I would like to encourage you, if you feel like any of the stories I'm sharing, any of the recommendations that they relate to you, you have experienced that in your organization, or if you have any questions, don't hesitate to add them in the chat. I will try to answer them by the end of the session, depending on how much time we will have. But if we will not have enough time, I will also answer later on in the GitHub repo, which I will share you in the end of the session, where you can read and find more resources on the topic. And also you can always reach out to me on the different social media channels that I will share afterwards as well. So a few words about me. I am a software architect based in Oslo, Norway. I have recently, in September, become a Microsoft Azure MVP, which is most valuable professional in the Azure category. I have been working with cloud technologies for more than 6 years now, mainly focusing on Azure, but I also love all things tech and all things cloud native. So I'm trying to dig into as many different domain areas as possible. And in addition to that, I also really love contributing back to the tech community, both by blogging and volunteering in different user groups and contributing to open source projects, and also as a speaker. So that's why I'm here today. And I also love cats, so you may see a few cat pictures during this presentation, so I hope this will not scare you away. And on a personal note, I am a Potterhead. I love hikes, puzzles, and also retro games. So maybe some of you may recognize the game on the right bottom side here, which is called Cow the Kangaroo. It is like from the 2000s, and I still play it sometimes because it still gives me this great nostalgic feeling. But enough about me. Let's dig into this exciting topic about managed Kubernetes service. And there are so many questions that you can see many people, many organizations asking and wondering about, because once you hear about cloud technologies, about cloud services, you may often think that a lot is being provided, secured, configured according to the best practices by the cloud service provider. And it may seem like if it is a platform as a service, then you might still not need to maintain and secure and think of that much. And the same applies to the managed Kubernetes service. If you think about AKS for Azure, or GK for Google, or EKS for Amazon, or other cloud managed Kubernetes services for in other cloud providers, you may also think that a lot may come pre-configured and a lot can be managed by the cloud provider, but it's actually not quite true. So if you would think about, wouldn't just the cloud service provider take responsibility for that, and the only thing I need to think about is to kind of package my application into some deployment YAML templates, and that's it, and it's production ready? In reality, it is not, and there are quite a few domain areas that you need to think about during the day zero stage of adopting a managed Kubernetes service. We hear a lot about day two, about taking your Kubernetes clusters, your applications hosted there, into production and start operating it there. This is kind of the day two operations that we hear a lot about, but I think it's really important to also raise awareness for the day zero and quite a few considerations that you may need to think of and prepare for when you are adopting, when you are designing your solution for your applications that will be hosted on a managed Kubernetes service solution. And I have been through a project where we failed on the first attempt on rolling it out to production. We had to roll back because we figured out that once it was out there running in production on the managed Kubernetes clusters, it was AKS for that project, we realized that we might have missed out on some of the things that we had to get back to the table and re-architect, re-implement. So this is also quite a story-based session where I would like to share my own learnings. And I took the challenge to do that in 40 minutes, so I really need to follow my time here. So we'll see how it goes. So the hard fact is that cloud, even though cloud service provider manages some Kubernetes components for managed Kubernetes service, typically it's control plane that is being managed by the cloud service provider for us. And it's a huge benefit in terms of reducing complexity for operational part of it. But still, there are many layers of Kubernetes ecosystem that are a shared responsibility and are a responsibility of us as consumers to take care of, protect, configure correctly, ensure that it's performant, redundant, available, and so on. And you might have seen there are many discussions out there about if Kubernetes is hard. And I can say that in the beginning, it has quite a steep learning curve. It has a lot of components. Just take a look at CNCF landscape of all the available tools out there that can help you, that you might need to implement to be able to ensure that you have a mature Kubernetes platform. But you just need to be prepared that it will be a continuous learning that never ends, because this is a technology that evolves really fast and there are constantly new tools coming out. So it would require some patience and preparedness for continuously learning new things, being on top of it, and also involving more people in your organization to work with it so that you are not the only expert. And as I just mentioned, day zero, which is about design and architecture of your Kubernetes platform and of the applications that will be hosted on that platform, this phase is crucial. And you must start with it early on in the adoption process so that you have enough time to prepare your organization and your development teams for it. And while thinking of that day zero phase, you should also think about layered approach so that there are many layers of creating a mature Kubernetes platform that is important to take into consideration in parallel. So it's about networking, about security, about architecture of your application. So it's important to take this layered approach and start small and expand, which we will learn more as we go. So what, if we get more concrete, more to the topic, what are those areas? What should you think about before going all in with a managed Kubernetes service? The most important domain that I would like to start with is the readiness of your applications that you are planning to host on a managed Kubernetes service on Kubernetes clusters. And this must be where you start by evaluating the state of your application architecture, because there are quite a few things that you should consider which may be different from the way you have been hosting your applications on premises, on the on-prem service, right? Versus what Kubernetes will require from you in terms of hosting. And some of the important points to think about is how many applications are you going to have? Like if you have a single application or if you have multiple applications. Are those applications single tenant or multi-tenant? Are those applications stateless or stateful? And of course, a big recommendation when adopting Kubernetes is that you should aim for having as many applications as possible to be stateless, because this is what makes it easy to scale and easy to scale fast. And um, this is something that you should think about. And if you have a stateful application, then there are quite a few things you need to account for in terms of how you will be preserving the state. What kind of persistence implementation are you going to have? You have a possibility to host your database, for example, if you need that, inside the Kubernetes cluster. But the question is, do you want that, or do you want to host it outside of the Kubernetes cluster? And there are pros and cons to both implementations, but you need to ensure that you have evaluated both and chosen the one that will suit for your use case. Because of course, storing a database inside the Kubernetes cluster will require quite a good level of skills in terms of operating the cluster and operating resources like database inside the cluster. And there are some success stories. So one on the bottom that you can see is from Forza Horizon 5, which is a racing game. And they have recently released quite an interesting success story, how they have taken their solution, which is based on .NET Framework, a collection of .NET Framework services that were deployed on Windows virtual machines, and then just they kind of lifted and shifted up to AKS, to Azure Kubernetes Service, and have been running those on Windows containers. And if you start kind of looking into the details there, it does not necessarily mean that you can take your application as is and just lift it to an Azure Kubernetes service. Because if it's a heavy monolithic application, it's one story. But in their case, they were able to succeed because they have a collection of microservices. They have a distributed system with around 17 lightweight microservices, which made it possible for them to run with Windows containers, because the services are so lightweight that they were able to scale fast. They were able to warm up those services really fast. So in case they have a heavy load, they have not experienced any challenges in terms of scaling. But if you think about a monolithic legacy application that can potentially end up in a quite large container image once you try to package it, it does not mean that it will be scalable, and it will not mean that it will be cheap to begin with. So one of the examples that I have experienced myself is that you need to think about how big the image will be in the end. So if you have a base image, you also need to account for updates and patches that are being released and are being put on top of the base image, which also increases the size. And then the size of your own application on top of the base image. How much in size will that be in total? So if that is an .NET Framework application, as an example, just .NET Framework 4.8 Windows base image is 5 to 6 gigabyte in size. And then if you put updates on top of it and the application on top of it, one of the scenarios I have seen is that it ends up on more than 10 GB in size. And just imagine if you need to scale that application fast, it can be quite tough. And if you have specific actions that require longer time for the application to warm up before it's up and running, it also adds up. And then you are not you do not have such a scalable application as you would have expected. So you should aim for looking into the application architecture and seeing if there are ways you can make it more lightweight. You can take out some services, for example, out of the application and run them side by side, because that may significantly improve the capabilities of your solution on a Kubernetes cluster. And another example you can see on the bottom there is about News UK, where they also moved and adopted Amazon's Kubernetes solution, which is Elastic Kubernetes Service. And one of their success stories was about moving a legacy Java application that was used for authentication and logging. And they also, if you read that article, you can find also their comments about that they were able to succeed with this because they had so lightweight services that they were really able to scale fast. So they, in case there is a high load, if there are some, some critical news happening there, then you typically will get much more traffic to your application. But since their services were so lightweight, they were able to keep their legacy application as is and still utilize all the amazing capabilities of the managed Kubernetes service in terms of scaling, self-healing, and so on. And other considerations that are worth thinking about are: what is the general strategy for your organization and solution going on? Regarding vendors, are you planning on only having a single cloud offering or multi-cloud? Are you planning on having a hybrid solution where you have some workload or an offering running in a private cloud setup or on-prem? Because then it would require for you to look into the ways you can solve it in the other ways, because you may not necessarily want to create different implementations for different cloud providers. You might want to utilize, for example, tools that allow you a cross-cloud implementation, like Terraform for infrastructure as code, right? And in like if we take Azure as an example again, if you would like to be able to run Kubernetes clusters on multiple clouds, you could utilize a service, for example, like Azure Arc, that will allow you to manage all the different clusters running in different clouds and running on-prem, for example, also through Azure. So you need to think about your strategy as a whole. And if you have, for example, a single application or a single service that you want to run, then having a full-fledged Kubernetes cluster where you still need to manage worker nodes, for example, that may be a bit of an overkill. So there you may consider, like, if you can go serverless, if you can utilize solutions that many cloud providers offer, where they fully manage the Kubernetes cluster for you, and you only pay for the containers you spin up and the time it takes to run those containers. Azure Container Apps is an example there, or Google Autopilot, or AWS Fargate. So there are some opportunities there where you can kind of go serverless on that, and that may be more than enough for you. Of course, it has specific limitations compared to if you would run a Kubernetes cluster as a whole yourself, but it still may be enough for your use case. So it's worth considering based on how many applications you have. Another important point is about organization readiness, and there you can see the CNCF landscape that I was talking about. There is quite much to think about there, and it is important to think about why you're doing this and why you're adopting Kubernetes. And if you think that you should do that because it's cool, probably that is not a good enough reason for change. So it is important to share and communicate the strategy and the values that this adoption may give to your developers, to your organization. You need to communicate this early across departments because, for example, business folks not necessarily understand what kind of benefit that will give, or developers don't necessarily understand what kind of benefit it will give for them. For them, it sounds more like complexity, that they need to learn something new on top of what they already have. So you need to be able to explain and communicate what kind of value it will bring to different departments and to you as an organization, to your users, the users using your applications. What can they gain? For example, faster releases, faster features being released for them, faster fixes, higher availability. So it's important to think about that and prepare your organization early on, so that they understand what it will actually mean, and it will change routines and the ways of working inside the organization and across teams. So it's important also to communicate that, so that different stakeholders understand what it means. And it is some of the considerations that I was thinking about are, of course, the cost, that it will require quite some effort to plan and continuously optimize the costs. As you know, with any cloud technology, the cost can go sky high, so you need to be aware and continuously optimize and see which functionality, which agreements you can look into implementing to be able to minimize cost but still provide the same level of value. And in the beginning, adopting such advanced technologies like Kubernetes, even if it's a managed Kubernetes service, it will require some time for you to learn and for the team members that will be involved in operating it, in developing applications for it. It will also be the cost in terms of their time and upskilling. So this should also be taken into consideration. And collaboration is the key, once again, so that you are not the only expert there. Collaborating, ensuring that the processes are improving and that the team silos are removed is really important. Then, while we are on the topic of the organization readiness, we also need to think about your developers that are developing and improving those applications. And if there are any developers here in this forum, you probably can relate to the notes that are presented in this slide. That most of the developers, they just want to code in peace and to be inside of their comfort zone and focus on bringing value to the applications. So they kind of making developers to learn new tools that they might not need to use on daily basis can become quite frustrating and challenging. And what many developers like is simplicity. They need to be able to have easy ways to get access to the environments where they need to test specific changes, or for debugging or monitoring purposes. They providing the complexity for them. If every step of the way they see an obstacle, it becomes really frustrating. And with Kubernetes, there is a lot to learn, so it may become pretty complex unless we can work on kind of reducing the cognitive load on the developers and simplifying their work with developing applications that are supposed to be hosted on Kubernetes. And there, from my own experience, I can also recommend looking into creating blueprint templates and creating some kind of internal portals, internal platforms that can abstract all the complexity behind Kubernetes, behind creating deployment templates for Kubernetes, and creating, for example, container images. So one of the technologies one of the tools I have been working with is, for example, .NET templates, which also has alternatives in other use cases. Is basically where you package a blueprint of a deployment template to deploy an application to Kubernetes that has all the best practices built in, packaged into those templates. And what developers need to do, they just need to create their own repository where they deploy this template, and the only thing they need to kind of think about is changing the configuration, adding the source code for the application, and not think about kind of how do you write these deployment templates. They can only change the values based on the need for the application, for example, how much memory, how much CPU it may require, and that's it. So they do not need to go into the depth of creating deployment templates and thinking about that. And if you have a self-service portal where they can, for example, easily generate such templates or create a playground cluster, let's say, that will also make it much more easier for them. And of course, having a possibility to educate them, to engage with them during the workshops and hackathons where they can get some hands-on with the technology early on could be really, really beneficial. And having automated checks would help you lots in terms of errors that may be added to the clusters, because when every developer needs to define themselves how the deployment to Kubernetes would look like, that may become a really high risk for human errors. So having automated checks that ensure that the best practices are followed, that can stop the deployment in case some best practices are missing, would really help a lot. And then about development and test environments versus production, there is a big difference that you would need to think about. And in dev and test, it's really tempting to do some shortcuts to kind of make it a bit easier, so that it's easier to just quickly deploy, to start prototyping, to start deploying your applications, to test it in development. But in production, of course, you wouldn't want that. You would need to secure, to properly configure the clusters to ensure that the users that are using the applications, their data is secured and protected, and that no unexpected behavior changes may happen due to the applications. And also you need to think about cost, which also requires different approaches when working with production cluster versus dev and test. And also you would want to make it a bit easier for developers to access dev and test clusters versus production. So that is also important to take into planning, that it may take less time to set up dev clusters than it would take to set up the production ready clusters. So this cost should be included into the roadmap, and it is important that the team that will be operating those clusters can start getting their hands on operating the dev clusters as well, so that developers don't do that, or that those clusters will not be left unattended, but so that operations team can start working with those clusters early on, so that they can get hands-on with upgrading those clusters, upgrading the node images, for example, and so on. So for that, what can help you lots is the reference architecture and the baseline documentation that cloud service providers have for each and every of their offerings. So there you can get a lot of guidance on how to configure that. And a good idea maybe to have a cluster that is as similar to production as possible, because then you get also this opportunity to run a set of tests on your application and on your cluster to ensure that everything is working fine for your applications with this configuration as well, and not only when it works in dev and test due to potential deviations in the setup. And here, one important thing that I want to show you is something that is called resource and request limits. And this is important to remember to set when you're creating your application deployment templates. What you can see here is a few applications where it was possible to make manual changes, and developers forgot to set the resource and request limits. And what you can see here, it's a bit blurred, but it's not that important for this use case. You can see that there are a lot of pods that are in evicted state, in image pull back off, in crash loop back off, and it is a huge chaos that has happened on that cluster, because if you do not define how much CPU and memory each and every application can use at its maximum, if you have a memory leak or a bug in an application that starts consuming a lot of memory or CPU, it may end up in consuming whatever it finds on that node, as much as that node in a Kubernetes cluster has. And it means that if it keeps running, it may potentially bring down all the other applications that you have running on that cluster, and you do not want that. So having automated checks that also can scan for if those limits are set could help also the developers to not introduce errors like this. So this could be really beneficial. And one more quick demo that I would like to show you, need to speed up a bit, but it's also about the health probes that can be important to set. So here we have a mission critical application that is up and running in a Kubernetes cluster. in AKS in this case, but I can show you now that what will happen if we do not set health probes for and will attempt to update or introduce a new version of that application. So what I'm doing now is that I am retrieving the pods that represent my application running in that Kubernetes cluster. As you can see in the namespace cat encyclopedia, I have one pod that is up and running. So what I will now attempt to do is that I will try to deploy a new version of that application. This app is packaged as a Helm chart. So Helm chart is kind of a way to standardize deployment of your apps. But as you can see here, the health probes for liveness and readiness of the application are commented out. So this means that if we attempt to deploy that version now, if we give it a few seconds, had to cheat a bit with the commands, but if we just try to run Helm upgrade to run the new version of that app, you can see that the version is different. Both versions have commented out probes. And as you can see, the new version of the app is faulty. So it has some bugs in it, which will not let the application actually to be ready to accept traffic. And as you can see, if you do not have health probes set, then the cluster does not have any reason to keep the previous version of the application up and running. So it will terminate it instantly because it says, okay, there is a new version coming. So I can just terminate the previous one because there is nothing stopping me from that. And what you've seen there is that the application went down, obviously, when you terminated the stable version and you have the new version that also is faulty, that is never able to start, and you have no criteria that is preventing it from from rolling back to the previous version, then it just goes back down. So the next thing that we will try to do to compare with that is that we will roll back once again to a more stable version, to the version that we had previously. That will be up and running right now. And then the next thing we can try to do is to deploy a new version of the application, but now with the health probes set. So what the situation will be is that the application itself is still faulty, so it still has bugs in it. But in this case, we will actually define the liveness and readiness probes, which our cluster will be able to look into and see, okay, my application is it faulty or not? Is it ready to accept traffic or not? And if yes, then only then it will terminate the previous stable version of an app. So let's see here. So now I will try to deploy a version of the app where health probes are set. All right. So now we can take a look at what is happening. And as you can see, the previous version, the first one in the list of pods, is still marked as up and running. So it is not terminating instantly like we saw in the previous case. And that's because the cluster was able to see, okay, I am testing these endpoints and the application is not ready. The pods are not ready to accept any traffic. So I cannot terminate the stable version of the app. As you can see, it is still up and running, which shows the importance of such best practices to be in place, to be implemented. And it's easy to forget. That's why having the automation for kind of best practice validation would be really, really important. Now, the next point is deployment strategy. And here many of you have heard about GitOps, and as Shakespeare might have said at some point, to GitOps or not, that is the question. And it is supposed to be the golden standard when you think about cloud native application development, where applications are hosted on managed Kubernetes clusters or on Kubernetes clusters in general. And GitOps is where you have your source code, your repository in Git as the single source of truth, and every pull request is considered to be kind of the new change. So there is that's the cluster that all the time is checking your source code and seeing, is there anything new that I need to update in the current deployment, and then it kind of pulls that information from the source code and performs the updates on the cluster. And it is of course beneficial to adopt GitOps, and this is something that you should aim for, but it is not always easy to start with that, and it still requires someone to have enough skills to maintain the GitOps tools that are handling this whole GitOps workflow. You still need to have a proper code review processes so that you ensure that the changes that are attempted to be added to the repository are properly reviewed, because if you add some changes, you cannot do manual fixes in the cluster anymore, because it will be automatically overridden by GitOps. The golden point of GitOps is that it prevents any manual changes. It always resets to the same state as it is defined in the repository. So all the fixes, all the changes must go through the repository. And you need to think about security and competence level of the operations in case anything goes wrong. Do you have a good observability of your clusters and of the GitOps tools like Argo CD, for instance? If things go wrong, is there anyone who can properly follow it up and fix it? So it's not always that easy to start with that. And I guess the goal, like my recommendation would be, the goal is that you can succeed with adopting Kubernetes without GitOps first, and then you can migrate to it when your organization is ready, when you have a mature and stable code review process and as much automation as possible, because this is also the key to succeeding with GitOps. You need to have a lot of automation in place to prevent any manual changes. So build maturity and simplify over time by moving to GitOps can also be a strategy if you don't have that much experience with Kubernetes. Then upgrade strategy for clusters and nodes. And I need to accelerate here. I don't have much time left, but this is also important because there are a few things you need to be aware about when it comes to Kubernetes, which still apply when you have a managed Kubernetes service. First of all, when you are doing upgrades to your nodes, they typically perform something called a surge upgrade, which means that based on on what you define, it can bring down the whole node and just create a new node on the newer version and try to spin up applications on that upgraded node. And this means that it will cause downtime to your application. So pod disruption budgets will help you ensure that this is done with zero downtime, because pod disruption budgets let you specify that I want so many instances of my application up and running at any point in time. So when it attempts to upgrade a node, it will bring down only that amount of instances of your application that you specify. So if you have four replicas of your application running in a node, it will create a new node, attempt to migrate 2 replicas at least of your application to that new node, and only when they are up and running, then it will bring down that node where your application was running initially, because you have specified that you want at least 50% of your replicas of your application up and running. And then you will ensure that there is no downtime to your application. Also, there are differences in patching of Linux and Windows node pools. For Windows, typically, you may not be able to have auto patching in place. You may need to ensure that you do re-imaging yourself, that you do a restart yourself. So it's important to familiarize yourself with the rules for different cloud service providers and ensure that you are following those. So security updates are not necessarily auto applied applied to your nodes automatically. You may need to do that and perform the upgrade yourself, so it's important that you know what rules apply to your cloud service provider. Also, for every new Kubernetes version, there are deprecations and removals of Kubernetes APIs. It happens really often, which means that if you upgrade your cluster and you do not check your deployment templates, you may end up in a situation where your applications attempt or resources attempt to call APIs that no longer exist, which will make them fail, and it will take longer time to fix it at that point ad hoc. So you need to look into ways of getting help to kind of get alerts if you have any deprecated versions that you're using, and tools like Pluto can help you with that. And also you need to think about version policies. If you have been running with an outdated version of Kubernetes for a long time, you may end up in a situation where a cloud service provider can actually perform auto upgrade for you if this version poses a security risk. So be aware of that and check that you continuously upgrade your clusters. And you can do it in two ways: in place or out of place, when you are spinning up a new cluster on a newer version and migrate everything, all the workloads to it. So you need to look into what would work best for you. A few things, we're getting closer to the end. A few more things that I would like to quickly share is cost and sustainability is also important. You can check out the materials afterwards where you can find the report about the trends on the cost, and quite many organizations experience that cost has jumped like during the time of their adoption of managed Kubernetes service, for instance. So you need to kind of always be aware of that and look into the different factors that may impact that, like VMs, VM families, virtual machines that you choose your nodes to run on. Windows may cost higher than Linux VMs. The deployment region, the prices may also differ there. If you have auto scaling, and you can potentially have, let's say, performance issues or some memory leaks or whatever issues in the application that may cause auto scaling to, create more nodes. And for each node, you may end up needing to pay. So auto scaling, you also need to have control there and set the limits. I have seen cases where the limit for autoscaling was set to be 100, and if you are a bit late on seeing that there is an issue and the autoscaling kind of is enabled and creating a lot of new nodes, then you suddenly have that limit to 100 nodes. You can end up in paying a lot more than you would want to. So be aware of those misconfigurations and auto scaling capabilities. And of course, those may be affected by the application bugs. So it's important to have a good alerting system and budget constraint policies set on that. And again, there are some optimizations every cloud service provider has, and you should consider cost management tools like KubeCost that can kind of visualize the trends for you. And there may be other optimizations like shutting down development clusters during the night when you don't need them, or using reserved instances where you commit to using these VM types for your nodes for 2-3 years, or spot instances where you can utilize underutilized resources in the cloud to a reduced price by kind of being okay with that they may go down at some point when cloud service provider would need them. And policy management also, that may help you to ensure that you have, for example, cost limits set. That will also help you to utilize your resources to their highest potential as well, which also results in better sustainability. And here is an example of Linux and Windows prices in Azure, for example, which are quite significantly different. Security, I don't have enough time to go into details, unfortunately, but you also need to ensure that you minimize the defaults. In some cases, you may just create the cluster out of the box, just as cloud service providers defaulted by configure it by default. And that may actually end up in a situation where you have a cluster that is publicly available to the internet, where you have Kubernetes API server available in the internet. And some of the reports that I share afterwards, you can read that there are quite many of such clusters all around the world that were discovered. So you need to ensure that you secure that and minimize the attack surface by utilizing private Kubernetes clusters, or at least authorized IP ranges and network policies. If you really want tenant isolation, just putting your applications in different namespaces is not enough. You need to use something like network policies to restrict who is allowed to talk to who inside the cluster. And container images are also by default running as root users, and examples may be as ASP.NET Core or Nginx base image. By default, they can use a root user. So you need to read their documentation to see if there is an unprivileged image version that you could use, or you need to add up your configuration yourself to restrict that and use another user. And security context in Kubernetes deployment definition can also be really helpful to have a double insurance where you define it on the container image level and on the Kubernetes deployment level. So do minimize defaults and do follow least privilege principle by minimizing who can do what. And there are quite a few frameworks out there that can help you with that you can check in the resources afterwards. I will be skipping a few things since I'm running out of time. So also you need to think about things that may fail on the vendor side as well. There are quite a few examples that you can once again read in the resources afterwards. So business continuity planning and disaster recovery is important to train upon, and there are some documentation out there that can be really helpful for you to practice that and ensure that you have implemented it in a good way. Chaos engineering can also be a good help here to simulate disasters and see how you can react to those and how good you are at fixing those and bringing your system back to the stable situation. All right, so last minute words, sum up the considerations. Do this adoption for the right reasons, for it bringing the value to you and your customers. Invest time and effort into the planning stage and utilize layered approach by starting small and expanding to every layer. Shift left, especially on security. Early involvement of the other teams and stakeholders in your organization, and common ownership so that you're not the only one owning your Kubernetes clusters. And be prepared for things that will fail, both on your side and vendor side. And don't forget the resource and request limits. And then you have an amazing managed Kubernetes clusters up and running for you. So if you would like to learn more, I have an extensive resource list that I have created for you. So do just scan a QR code and do reach out to me if you have any questions. I can talk for hours about this topic. So I see I'm running a few minutes over time already. I see there is one question. I can quickly answer that since this is being recorded. There is a question from Rafal, if it is worth to deploy a web application with database in Kubernetes. Shall we see how to prevent bugs on database? I mean, I can say at least that if you can utilize, for example, if you're talking about the blog where you are using, let's say a WordPress, right? So if you're using some third-party solutions that you build upon, then a lot can be done for you in the Helm chart. So you could utilize that instead of creating all of this yourself from scratch. But if you nevertheless create a full solution where you require a database, from my experience, I would recommend to not start hosting database inside of a Kubernetes cluster, because this has quite many challenges and requires quite advanced skills in terms of operating that inside the cluster, because there are so many pieces that may go wrong, and Kubernetes was initially created for stateless applications in the very beginning, though it has really become much better now. But I would start by hosting database storage outside of the cluster, and then see if that would bring any value to host it inside the cluster as well. So I would say, if you were to deploy that, start by deploying the services that are for state outside of the cluster. And then I will answer the last question on preventing the bugs on database, like overriding data, after the session, since we're running almost 5 minutes over time. But if you have any other questions, don't hesitate to reach out. And thank you so much for listening in. I wish you a great rest of the Positive Technologies conference. Thank you so much.